Siemens Step 7, an absolute beginner's guide to PLC programming. Hey guys, I'm coming to you out of my hotel room here in Anderson, South Carolina, giving some training to one of my clients right now. And as I have promised, I will record now number 7 of the 8 videos of that course. Many of you have asked me in the past, where's video number 7 and number 8? Well, here it is. Let's dive right in. A little disclaimer though, I switched to Siemens PLC V15. I'm working on Windows 10 now, and in order to simulate stuff and use the Siemens PLC simulation, we have to actually use the V15, because on Windows 10 PLC sim of the PLC doesn't work with the V14, unfortunately. So I drop a link into the description of this video down here where you can download that. So let's dive right in. Let's open up PLC V15, and we will start with a fresh program. We'll basically just like repeat what we did in the other 6 videos. We'll just use S7 graph this time, and then in video number 8 I will show you how to create an HMI and show you the basics of that. Well, let's dive right in. Have fun, guys. I hope that will help. So first things first, let's create a new project. That's where we go on project and say new, and then we create a project called training S7 graph timer. Create. That might take a while to create a project. I'll just fast forward it here. Alright, so first of all, we got to create a new device. In order to program S7 graph, we have to actually use an S7 1500. It's not going to work on the 1200 though. So first of all, we have to add a new device right here in your project tree. Double click add new device, and then we can choose from a drop down menu here S7 1500, and we'll just go for, let's say we go for 1512 Profinet. So using that one, click OK, and we'll automatically create that device, and also automatically update the open up the device and network view for the hardware. Come on. So, and then first things first, because we are using the clock memory bytes that come on board with the PLC, with the CPUs, we actually have to activate it. So we go on properties right here, click on properties, oops, click on it again, and then we're looking for something called system and clock memory, right? And then we are enabling the use of system memory byte, and then also enable the use of clock memory byte, because we actually want to use the 1 Hertz clock bit. That is the global memory 0.5, clock 1 Hertz. Once we have done that, we can dive right in, go over to our project tree here, where the program blocks folder is. Click on the drop down and say add new block. First of all, we want to create some data. So we create a data block, call it time data. Click OK. That will create our global DB right here in our project tree. And then we are creating a structure called times. And in this tutorial, I will only use just one single device to get quick through it, but you get the idea from the other videos that you can recreate that as often as you want with multiple devices when we're using FBs. So that boolean we will change into a struct, enter, and then in that struct go our seconds, and that will be integer whole numbers, int, enter. So seconds, minutes, hours, and days. That would be our data. And then let's create a new block where we actually program with S7 graph. So go on new block, and then when the pop-up opens again, you got to be careful. We can only program the S7 graph in function blocks, not in functions. If you look into function, you see that it's available ladder diagram, function block diagram, STL and SCL, but not the S7 graph. So when we click on the function block though, and open up that drop down, then you can see here the graph. We can actually choose the graph, and that's what we're going to do. And then just call it counter operating hours S7 graph. Alright, and then just either click enter or click OK, and then it should open up automatically. So the S7 graph, it is a really nice way to do step sequences, and it's mostly used by the automotive industry all over the world. So the major OEMs, so I'm talking about all the car makers actually, they're all using S7 graph or step sequence programming languages to actually accomplish their tests, because what is often is that the PLCs in those facilities actually controlling robots, and there's a lot of handshakes going on, and that's why they're using those like visuals, the S7 graph, for their programming. So let's dive right in. So what are we actually going to accomplish? We want to count up seconds every time the clock 1 Hertz bit comes on. So in order to achieve that, this time we are using the S7 graph, and I didn't prepare myself for that. I'm just diving right in. So the S7 graph contains two different things actually. So you have your steps, that's those guys here, right? And that's actually where you write your code, that what should happen, right? What should happen if this is if this step comes on, this will happen. Whatever you write in here will happen. And then the next thing is if you want to create the next step, you would just go and say, okay, create step and transition here. And then that transition here, T1, if we open that up, you can actually see what it is. It's a little ladder diagram network, right? So in order to go from this step here to the next step, this here has to become true. Whatever you write in here has to become true. So you could either write it right in here, whatever the conditions are, or you can use collector bits where you collect information out of a bigger network somewhere else, and that somewhere else would be your permanent pre-instructions. So if you click on that one, it will actually open up a ladder diagram function block, if you want, so like you know it from the original ladder diagram function blocks. And then you could say, okay, whatever is true here, let's say you have a couple of conditions here and then a coil, and that coil would be your collector bit. And then that coil you would use in your sequence here, just in order to make it better to digest when you look at it, because you're only looking at the collector bit here, and then only if that bit doesn't come, you can go and say, okay, so my transition 1, I actually go over here and look into it and see what is missing here. So those numbers here, normally they're networks. In this case, it's actually your transitions, right? So I'm going to delete that here again because I want to start from scratch. I'm going over into my sequence, and then the first step would be a no action step. So where is it? So we're creating a no action first of all, so we will do it like that. And you can see, like, every time I create a step, it automatically writes that into the static area of the function block data area. If you open it up, you actually see like all the different things that are shown in that step here. So if you open that up and you go and add new, you see qualifier, all those things, they're in here. So you have your S1, L1, V1, R1. That's all in here, but we don't care about that just for now. So what we're gonna do is, like, we start writing our code. So we need a little bit of data. We go in the static area. We will add row and then create a piece of data that says no action. Alright, but the data type will automatically be the one that is above. We don't want a G7 transition. We actually want a Boolean. So bool, enter. And we're just using that every time when we don't want to do anything in a step. So that would be our initial step. So qualifier, we set something, all right? We say n is set as long as step is active. We say n, and then the action would be no action. So if you write it like that, it will just set it. Well, it will just like invert the bit when it's a Boolean. You can also like write something in there like an integer name and then say set it to something. So, but we don't want to do that. So in this step, we will just say no action, right? And then the transition to that would be our start of the counting. So we go into permanent pre-instructions, all right? And then we say normally open, clock 1 Hertz. So every time that happens, we want to actually say P trigger. That means like we are just looking for the positive edge of that bit. And then we're also creating something like our work bits. So let's say we say work, and then we make that a structure. Struct. Alright, and then in there we put triggers, and that instead of a Boolean, a single one, we will say array parentheses. Oops, that's the wrong ones. We're actually looking for those. And then we say 0 period, and then let's say we need 10 just to make sure. And then close the parentheses, and then we say off bool. That will actually create an array of 11 booleans, and it's kind of like hidden in the structure. So if you click that drop down menu of triggers, it will then show you, okay, we have triggers, and then we have it from number 0 through number 10, so 11 of them. I think that will be enough. So now let's go back into our code and we say, okay, this will be work, triggers, and then 0. So every time that happens, right, we give it a collector bit. So, and those collector bits we have to create also. So let's say second one will be collector, and that automatically creates an array of bool because the one above it was the same. So let's say this one, coil, and there we say work, collector, 0. And let's just call that step or transition. So now we're going back into our sequence, and now here in our transition we just say, okay, we take a, where is it, normally open, and say work, collector, 0. So whenever that bit comes on, we will be able to go into the next step. Okay? So our next step then, so what do we want to do? So what we're going to do is we do something, and in that case we say set as long as second step is active, but then we say event, and we are looking for incoming step S1. Alright, so the action will be, and here comes our data in, so our data is stored in times data, right, and then period times period seconds, and then we say double point equals, and then we say times data period times period seconds, and then plus 1. So that means when that step becomes active, so just the first time, right, we take our seconds and add, and move seconds plus 1 into it. So it's kind of like we did in the other videos when we in the SCL language, where we use that kind of syntax too. So that will, every time that comes on, we'll add 1 into seconds and count it up. So we're using the positive trigger and then just like going into there. Alright. So let's go into the next step. So what we're going to do is, like, we're going into our permanent pre-instructions. Okay. And then we actually have to Control R will add a new network, and then we want to create a comparison here, and we want to compare for greater or equal, and we want to look for time data times seconds. If that is greater or equal 60, we want to do something. In that case, put a call in and say work collector 1. So, and then we go back into our sequences. So now we have done that, and then we say, okay, do something here, and we are looking for a normally open, and then say work collector 1. So when that is true, we go into the next step, and then we can just go on this arrow here and say create new step and transition, and it will automatically do that for us. Oops. Right. So now we have step 3 and transition 4. So in step 3, we want to do the following. Again, we say incoming step, and we say n, set as long as there, and then we say action will be time data period times period minutes double point equals, and then again time data period times period minutes, and then we say +1. All right. So actually, is n the right one? Let me check. What else? What we have? Set to 1. Yeah, I think n is the right one. We will check that later when we start the simulation. But okay, does that make sense? No, not really, because like we actually have to count up to 60 here and not just to 1. So when we start the program right now, it just counts to 1 and then waits for it to be at 60 or greater. What will never happen, because we actually have to create a loop. In order to do that, we're going on the step number 2, highlight it, and then you go on, where is it? It's actually this one here. So it is actually opening up another branch. You can actually think about it as an else statement or an or instruction. So click on it and it will open up another branch here. So with another transition, okay, and in that transition, instead of like writing it into a network, we will just say, okay, compare, and say we want to look for smaller than. Okay, smaller than, and we say time data times seconds, and then should be smaller than 60. Enter. And then if that is the case, we want to actually jump, and then that you can do with that arrow S. Okay, jump, and we want it to be jumping to the end that we didn't create yet. So in order to create an end, you actually go to the last step. That would be here, the arrow that points down, and you click on this one here. Okay, sequence end. You put an end on it, and then it will create this bubble at the end here. Okay, now we can go ahead and go over there. Oh shit, I didn't. Wait. Now we can go over here. Click on that one, say S, jump, and then we will actually, why doesn't it show it to me? Jump to, why is it not possible? So, alright, we gotta actually create another step in between there. Let's do that. Let's say, okay, we go on T4 and create another step, just a step here, and create another piece of data, and let's call that end, but this time it's just a single bool. All right, and then we will do it like that. We say n. Let's put it like set to 1. Okay, with an incoming event. Oops. Incoming event S1, incoming step, and then we say. We say, wait, it lives in work period end. Alright, so now we have set that to 1, and the only thing that we are looking for in that transition here would be a normally open, and we say work end. So if end is active, what we will select active. If end is active, we will give the transition free to actually go to that, and then it will start from the beginning. So it will actually jump back to the start of the whole thing, right? And then in step 1, let's do something else. Let's reset the variable work period end. So we actually reset that. And now we can go to our second branch here and say, okay, click on this one here, oops, on the arrow, and then we say jump, and then we say jump to step 4. Alright, so this is here where it jumps to, and the only thing it will do afterwards is like set work end and then transition out, and then we'll jump back to this one. And that's how we created the loop. Okay, so once we reach the 60 though, it will add 1 to the minutes, but that's not all. We also have to reset the seconds in order to then count back up to 60. So what we're going to do is this here. We say S1 incoming step, and we say N. Alright, and then we say time data period times period seconds, and then we say double point equal, and then we say 0, and that is how we move a 0 in that piece of data. So now we kind of have to repeat that for the minutes, for the hours, and for the days again, in order to count it up. So let's dive in. We open that one up. So now that we are counting up minutes, right, we are going to our permanent pre-instructions, and we are comparing. So click on 2, Control R will open another network, and in here we will compare. Basically we will do the same as here. We just can copy and paste that. We just have to differ it a little bit. Wait a second. Copy, paste. Okay, now the only thing we have to do here is to say delete 2. And the only thing we have to do here is say it's not seconds, but it's minutes. Okay, so now we go back to our sequence and say here we're looking for a normally open, and then, well, you know what, let's do it differently. Let's click on step number 3, because transition 4 is actually for step 4. Let's click on step number 3 and then open, click on create new step in transition. Let's do that. So it just created transition 7 and step 5. So it's a little bit messed up, but we can change that later, so everything is in order. So let's open that up. Normally open. We're looking for work collector number 2, I guess it was. Alright, so that will then go into the next step. If we reach the 60, right, but we actually have to loop it through again in order to actually get there, right? So in that case, we say Well, actually, let's do it differently. Let's ask for those two conditions to be done instead of that, and then go further. So let's delete that. Let's go back to our parent preconditions, and let's say we don't need that. We're actually looking to compare, or this time we want to have equals 0 for the seconds, and what was the other one? Let's look for the seconds, because the other one would be like a change that would like be too much here for that course though. Alright, so we're looking for the seconds to be 0, and then let collector 2 be active. So let's go back to the sequences, and then we did that, and then collector 2 would be right. I'm sorry about that. Collector 2, oops, of course not, of course it's work, collector 2. And then the next step would be us counting up we're counting up, so we say qualifier would be n, and then we are looking for incoming step, so we're counting up. In that case we would say time would we? So what have we done here? We're counting up minutes. Let's do a no action step. Let's do no event. Let's do no action. Okay, no action. And then this one will be no action. Create a new one, step, okay. And then here we would actually compare, wait a second. So we have counted up the minutes, and this one we're looking for no action, and then we're not looking for no action, we're actually looking for work collector 3. Collector 3, let's go back into our pre-instruction, and here we compare to, let's create a new network, Control R, and then let's create another comparison, and this time again we go for greater or equal, and then we compare the time data times minutes to 60, and then do collector 3. That would be normally open. No, wait, stop. The coil, and then work collector 3. Alright, so back to our sequence. So if collector 3 is there, then we will actually do something. So collector 3 actually will do this: incoming step, n, set as long as step is active, and then we will do the following. We will say time data, period, times, period, hours, and then double point equals time data, period, times, period, hours, and then plus 1. Alright. Plus we also do this. Sorry for that little screen though. So we say S1, and then we say N, and then we say time data period times period minutes, and then double point equals 0. Alright, and then in this one that would be collector 4. Collector 4, I'm sorry, work, of course, work, collector 4. But of course this will not be reached at all times. So what we're going to do is either we get collector 3, or we click on this one and open up another branch. And in that one we're looking for comparison. Let's say this time equals. No, wait, stop. We said is smaller than, and then we are looking for times time data times, what was that? I think it was the minutes this time. Minutes smaller than 60, then jump to, what was it, step number 4. So again here, like we're jumping out of the loop, we set work to end and then just jump right out of it, and then it will be a loop. Alright. And now we have to do it again, but not before we created the permanent pre-instruction for the collector 4, because we are actually looking for, we compare, and we say equals, and we say time data times, and then I think it was the minutes, and if they are 0, and then we are writing the work collector 4. Alright, so go back to our sequences. So collector 4 is true, and then we want to actually do something more, and in that case we create another step in transition. That's step number 7 in transition 10, whatever. In that step we want to do another no action. Oh, wait a second. Qualifier N, no action, and this one we would look for, wait a second, this one we would look for collector number 5, work collector number 5, right? The only thing it looks for is that we have, oops, create a new network, we compare, and we want greater or equal, and that would be time data times, and we're looking for the hours, and then that should equal 24, right? So that would be collector number 5. So that's work collector 5, and then we go back to our sequences and say, okay, collector number 5 is right here, but what if that doesn't happen? Then we say alternative branch, and we jump out to step number 4, and it does write that, but we also have to say, okay, we're comparing and say smaller than, we're comparing the time data times hours, and we say smaller than 24. Right, and that like jumps out of the loop. So now one thing left. We're clicking on this one here and say new transition and a new step and new transition. That's the last one. And we say event incoming step, and we say n. And then what we do is time data period times period days, and then double point equals, and then the same time data period times period days plus 1, and then also s1 n, and we say time data period times period hours, and then double point equals 0, and then we jump out of there, right? So now let's see if our data actually counts. First of all, of course, we have to call that function block in the OB1, because right now we did write the function block, but we didn't call it. So open up OB1 in your project tree, see that, put in a new box, and say, what did we call it? Counter. So it should show up here, right here. That's our counter operating hours S7 graph. Click on it, enter, and then it will ask you to create a instance data block. In the OB1, there's only single instances possible. You created that, and then it was actually like creating all this for you, right? And that is kind of like the way to like control it from outside. Okay, we are not looking into that right now. Let's try if we can get it to start up. So click, highlight your PLC here. Maybe we should save that project one time. So highlight your PLC here, and then you click on this icon here, start simulation. We're starting the simulation. So simultaneous blah blah blah. Just say okay. Okay. And let's see what happens. Minimize that. Load. Finish, and then check if it's running. So in my case it's not running, so yeah, I have to click run. So PLC is running. I'll minimize that. Then I'm looking into my data, and I use the glasses here to monitor and see what happens. Alright, so I see something happened there. Seconds counted up 1, but it's not really running. So let's look into what the holdup is here. So counting operating hours, and I will close this here, and I will just do the same here on monitor and see what's going on here. So right now we have work end is true. Okay, so first thing ran through, but it never went into the loop. So what's that? Well, that is something where you go back into your OB1, because we didn't say that this should run in auto mode, right? So it can work. We actually have to initialize the FB with an impulse. So because we know that our clock 1 Hertz bit is like on for half a second and off for half a second, if we just use that impulse, it actually only will count up like one every 2 cycles, every 2 seconds. So we're just going on the init SQ, and we say we want to use the clock 2 Hertz bit. That gives us a little bit of like a heads up on the because that's on for a quarter of a second at a time, but then twice a second. So we will do this. We put it on there and then load it in there, and then let's see what happens. So now load, and we go back to our data and see there it's counting up. So let's cheat a little bit. Double click on it and let's modify the bit integer to 58, and then see what happens. Boom, counts up the minutes. Okay, let's modify that one to 59, and let's modify the seconds again to 58. Okay, that counted up the hours, and let's cheat a little bit more. Let's say the hours are 23 and the minutes are 59 and the seconds are 58 again. Boom. So our counter is actually working. So if we go through back to the S7 graph and close everything up with the button up here, that will close all the networks, all the steps. And if we go on monitor again, then we can actually see what's happening here. Okay, but because we're like doing an operation that is so quick, we only see step number 1 blinking. Like the other steps we won't even see, because like the TIA portal is not fast enough to like showcase it in a graphic when we are talking about like milliseconds and stuff like that. We might get lucky and we might see something when it switches to minutes. Maybe something else blinks right here. No, we're not fast enough. So, but as you can see, we're running through the steps perfectly, and we have 1 day, and like it's counting through, right? We have 1 day, 15 seconds and a minute, and 0 hours. And if we test it again just to make sure, we cheat it up to 59 minutes and to 23 hours, and then let's see if it counts it up, and if we can count in a second day. That's probably like if you test it twice or 3 times, you are on the safe side that everything works properly. And this will in 14 seconds kind of conclude our lesson here, and I hope you enjoyed the video. And let's see, 58, 59, alright, counted up to 2 days. Well, I hope you had fun and learned a lot. So don't forget to subscribe right here, and then hit the bell to get a notification every time I upload a new video. I will be better on that, I promise. I will upload a bunch of new stuff anytime soon. Please also like consider watching my Core of Success videos that I lately started uploading, and I will see you in the next video. Thank you very much.